Hi students, this video is on the periodic table, a very basic overview. The learning goals for today is that you will be able to read and understand an elemental square and find any element on the periodic table when given its atomic number. To start off, we are going to watch a video from a teacher you know. The periodic table may be something that looks a little intimidating and confusing, or maybe something that gives you a sense of comfort that there is order to the universe. We're going to learn a lot about this year, but just to do a brief overview of some of the different things that you're going to learn, let's take a look at some quick patterns that you may have not noticed before. If I look at the periodic table, it kind of looks like the numbers are sort of random. But if I notice, the numbers count up actually from left to right. That counting up is actually the element's atomic number going up every single time we go one square to the right. And what's happening is we're adding a proton every single time we go to the right. So all of the names of the elements, in one sense, are sort of inconsequential, or they don't really matter, because the best way of knowing an atom's identity is knowing its atomic number. The atomic number is the number of protons in the nucleus, and that number will determine the element. If you change that number, you will change the element. You know this by going over to oxygen over here, and if I go down 1 to 7, I've made it nitrogen. If I go up 1 to 9, I've made it fluorine, and so on. Another interesting pattern in the periodic table as you're just trying to navigate it is that it actually doesn't read very easily at the top. Hydrogen, being the first element, has 1 proton, but where's 2? Well, I actually have to go all the way over to the end to find 2, and this is helium. Helium has 2. There's a reason it's over here, and it might seem a little confusing now, but we're going to learn why these colors matter very soon in the course, and you'll learn a bit more about the patterns and the amazing organizational structure that's behind the periodic table. So finding the number that goes next just takes a little bit of understanding how it's put together. It's just reading from left to right. Hydrogen, helium, lithium, beryllium, where's number 5? 5, 6, 7, 8, 9, 10, and then back over there to get to 11. And then once you get to this bottom part, then it just starts to read from left to right. Well, almost. There's this little piece at the bottom. We'll learn about all the rest of the patterns and how to organize it, but really all I want you to get at this point is that an element square is got a lot of information in it, but once you know how to read it, it becomes very useful and easy to understand. Okay, so elements and the periodic table, it's a tool. It's something that you've got to learn how to use. And in fact, I'm supplying one to you. So this is the official periodic table that we're using. It's up to date, and because they actually have discovered new elements and needed to put them on there. So there's some important things that you have in this course, and one of the most important things that you have as a material, in addition to a notebook and a computer, is your periodic table. Yes, you can get them online, and yes, I'm going to send it to you digitally, but print it out. I have mine printed out, and I keep it with me right over here at the side of my table, because I always want to access it very quickly, and I have that giant one right behind me. So you want it to be super available, especially in the future units that we're going to use, where you're accessing this thing all the time, because it has numbers on it that you will not want to memorize, and I'm not going to ask you to memorize, but you will need to know what they are and know accurately what they are. So we have to use it as a tool. Well, let's review a couple of the things that were mentioned in the video. The atomic number is the first piece that was mentioned. That atomic number is the number of the protons that are in the nucleus. We've said this a bunch of times, but I want it to be super clear. It's the number that never, ever, ever changes. The proton number defines the element. So, for instance, the element carbon is defined by having 6 protons in its nucleus. There's 6 of them, and if you change that, if you go up the periodic table, you're going to change it into another element, nitrogen, which has 7. And if you go down the periodic table, you'll change it into boron, which has 5. The atomic weight, this is another term here that we actually haven't quite investigated as much in class yet. Atomic weight is similar to mass number, but it's actually more useful for calculations we'll do later in the course. And then the symbols, this is the letters here. So you notice these letters are just single, it's B, C, and N, just single letters. Silver is AG, but I would not write AG. That's incorrect. And the reason is that way if you put multiple elements together to create a molecule or a compound, you don't get confused by saying which element is which. Or are you talking about 2 elements or 1 element? That could get really confusing if you used all the same case, all uppercase or all lowercase or something. So we always use this naming scheme where the first letter is always capitalized and the second one is always lowercase. Now, let's see if you can get these questions correct on a couple practice problems. How many protons are in carbon? See if you can get the answer. Now, we see in the element square that there's just 2 numbers, a 6 and a 12. Well, this 12, especially because it's got a bunch of decimals after it, this is the weight, right? This is the atomic weight. But the atomic number is the number of protons in the nucleus. So this number is the number of protons, 6. Okay, a little bit harder. Let me move myself over here. Now, which element has 15 protons? Let's see if we can get this one. Well, I don't know exactly where 15 is, but let's see. Here's 12. I'll go over 13, 14, 15. Phosphorus. P. Okay. Which element that's neutral? All elements are neutral, by the way, if they're considered elemental. Has 27 electrons. Well, wait a second. I never talked about electrons. See if you know the answer, even though we never talked about electrons. Okay. Now, even though I never said electrons, if it's neutral, the electrons have to balance the protons. So actually, the atomic number stands for both the number of protons and the number of electrons, considering that most of the time we're dealing with neutral atoms. If we're not dealing with that, we can't always say that that's going to be true, but we will still learn something about how many electrons we should expect to have if we know how many protons we should have. Even if it's charged, it will still give us some information. So let's find element number 27. 19, 20, 21, 22, 23, 27. Cobalt. C and little o. Okay? And what is the atomic number for Au? Well, I don't even know what Au is. So now I have to look through the entire periodic table and try to find Au. I hate this kind of question. I know. I wrote it. But if you look enough, eventually you'll find Au is right there. And it is a good idea to just try to look through all of the stuff in the periodic table and try to get familiar with all the different elements that are in there. Here's iron, and over here is tungsten, which they put in light bulbs. There's uranium down here. Just look where things are and try to get a handle on where things tend to occupy. Silver is close by, and it's just helpful to kind of see where things are. So what's the atomic number for Au? The atomic number for Au is 79. Okay. I think that's it. I hope that was helpful on the basics of the periodic table.